Okay, to work on the snazzy fast Fourier transform routine for Chem 101, fall of 2015. The next task is to create the Fourier Abscissa for the Fourier transform data. Now, this is going to be equal to 2 times pi times the quantity 1 over delta t times the quantity index over the total points here. Okay, so that creates a counting number that goes from 0 all up to 1 over dt. So there it is. I'm going to save this. Now, the next thing is to create the Dft signal. And the way to do this is to go to Data, Analysis, Fourier. You can OK that. Set the input range to be the noisy signal here. There we go. Set the output range to be that top number in that block, and then say OK. So there we go. So now we have a column of complex numbers which represent the Fourier transform of this noisy signal. Now you notice it's a complex number. First one's real. All the subsequent values are complex, which means they have a real component, and then plus or minus an imaginary component, that is a component that's multiplied by minus I, or by I. So the So I have to undo that. I made a mistake there. So now another thing we want to do is we want to record this process as a macro and assign it to a button. So I'm going to I'm actually going to delete this button, and I'm going to delete this range of values, and now we're going to go ahead and record the macro that did what I just did. So here we are in the spreadsheet. I'm going to go down to the lower left, click on that thing there. I'm going to give an FFT as the name, and I'm going to replace it. That was an existing one. Now that the macro is recording, I'm going to go to Data Analysis, Fourier, OK. And now the input range is the noisy signal. The output range is there, that's correct. So now I'm going to say OK. And now when that's done, I'm going to stop recording. Now if we go to Developer, Visual Basic, we can see what we just did. There's FFT, Application Run, Fourier. There's the input range. There's the output range and the 2 false booleans. Then there's a scroll down to bring us to the top. I'm actually going to leave that there because I think it's okay. Save the project, go back. Now I'm going to make a button to run that Fourier transform. Also from the Developer tab, I'm going to insert a button. I'm going to place that button right about here. And that is going to run on FFT. And I'm going to name it Run FFT. Okay. Click outside the button. Now the button's operative, and we can run it. If there's data there, it's going to prompt to overwrite existing data. Press OK to overwrite. Yes, that's OK. And there we have it. Okay. So now to graph the data, we need to take the absolute value, or really the vector sum, of the real and the imaginary parts here. So we're going to take the equals IMABS of the complex value there, create a new real value, And I'm going to propagate that guy down. And here we have it. Now this is a graph of that function there. So, save it again. That looks beautiful. What we see here is Fourier components at the low frequency end, then a pair of spikes representing the low frequency, low amplitude, and the higher frequency, higher amplitude components, noise components in this data. Then what we see is that actually as we increase the value, then there's a mirror image in the Fourier spectrum returned by Excel. And so these are nearly mirror images here, and I'm not exactly sure why Excel uses this format, but the frequency essentially goes from low to maximum, and then from maximum back down to minimum. So don't let that freak you out too much, but that is one of the idiosyncrasies. So now we're moving along. I'm just going to do a little cleanup here. Take that guy, go to Home, Page Layout, Start, Formulas, Data, View, oh God. We want to clear the formats. There we go. Now I'm going to take this data set here, put a box around it. This guy here, put a box, put a box, put a box around you, and you, and you. And now we have the Fourier domain signals here. Now the next thing we want to do is define a filter function, and that's going to be a real value between 1 and 0. So I'm going to merge these cells together here. I'm going to write the value, right filter here. And I'm actually going to tilt it up so that it looks like that, because I'm going to make it fairly skinny ultimately. This is a real value. And this guy is going to contain a fairly complex Boolean. So I'm just going to copy it and I'm going to paste it here. And enter that guy. Oops. That did not work, so I'm going to try again. Control C, escape, Control V, and enter. Great. So I need to adjust this value D16 here to be actually this value, and this guy to be also D14. And then now that having been done, I can propagate this guy down. What we see now is that this value is either 1 or 0, depending on the value of the cutoff. So if we made this 10, then the first 10 points will be 1 and the rest will be 0. Until we get down to the bottom of the data set, where we will find the complementary 10 points at high frequencies, or at the highest frequency. That's to accommodate the folding thing that Excel does here. Okay, so why is this a filter, you may ask? Well, let's just see what we can do with it. Let us take, make a new column here. We can call this guy the filtered Dft, And this guy is going to be equal to the IM product. That's how you multiply things with complex numbers here. That is going to be equal to this number times this number. Okay, there we go. There's a real number. Oops, I made a mistake there, didn't I? That is in number 13. I'm going to move this down. So that's 4. That should be 13 times 30. 14 times 14. That's correct. Good. So this is a complex value out there. And there it is. And I'm going to propagate that guy down. And you notice that it's equal to this value until we get to the zeros, and then it's 0. Okay. So, save. Now I'm going to add to this plot, I'm going to add the filter function. And I'm going to go to Format, Design rather, select Data, add a series, and that series is going to be filter. The X values are going to be the Fourier Abscissa. Alright, and the Y values are going to be the filter. Okay. Alright. Okay, that. Now we have a red line at the bottom here, and I'm going to fix that so that we can see it. But before I do that, I'm going to add one more plot here. Go to Format, rather Design, select Data, add a third, which is going to be the, oops, sorry about that, guys. Third one is going to be the filtered Dft data. The X values will be the Fourier Abscissa, and the Y values for which will be the filtered data here. And go there, and OK. So, now let's do a little work on this guy. We're going to format series filter here. We're going to format that selection in such a way that it is on the secondary axis. So what that's going to do is going to create a y-axis off to the right here, and it's going to plot that data set versus that axis. Okay. Now I would like to do that one more time, and I'm going to take the third series, the third series, which is going to be filtered Dft, and I tried to graph a complex number there, so that's not going to work. So what I'm going to do now is I'm going to make the new magnitude of that. So this is going to be the magnitude of the filtered Dft. Okay, so let's merge and wrap and center that guy. See how that comes out. This is going to be a real number. This is going to be equal to the IM_abs of this baby for plotting purposes. Propagate that guy down. Alright. So, now let us just select that data point here. And let's move that guy here. Okie dokie. So, let's also move the name there. Okay, let's see how that works out. So now we have the gray is allowed to go through, the blue is filtered, and then the red is the filter function. Okay, so now I am going to, now that's actually all we need to do in this domain. So cosmetics here, putting boxes around stuff, it's extremely complicated. And then boxes, and then shift control arrow down on that guy, put a box, shift control arrow down on that guy, put a box, and now we are ready to go back into the time domain. So this stuff was all in the frequency domain. So I'm going to make that actually blue. Make the letters blue there. And I'm going to make these guys also blue. Blue text. And then I'm going to make this I'll make the background blue, and then make the text black there. And I missed you guys, didn't I? So I can make your text blue and your text blue. Oops. Make your text blue, rather. Didn't mean to do that. I meant to do that, and then that guy is going to have a blue background. Okay, so I think that's good. Now we're going to go back into the time domain, which is green, and we are going to make an IFFT. Okay, so merge, wrap, center, blah blah blah. This is going to be inverse of the FFT of the filtered signal. Okay, put a box around you. Now, this is going to be also a real number, I hope. But this is real, and it's in the time domain, so it's going to be green. Oops. Sorry, it's going to be green here. And this is going to be green text here. So let us see. Let's record the macro to do the inverse Fourier transform. IFFT. Say OK. Now we're going to go to Data, Analysis, Fourier. OK. The input range is now going to be the filtered Fourier data here. And then the output range is going to be here. And we are going to inverse transform that. Okay? So there we go. That is all we want to do on the macro. So we're going to say OK there. And now to get this thing to work again, we're going to have to, it returns a string, so we're going to have to say equals 1 times the value in that string, and that converts it to a number. Okay, so now what we want to do is we want to copy this baby over here, and we want to plot now, we want to plot this guy versus this guy. Okay? So now there is the filtered function. And what we'd also like to do is we'd like to add the original noisy data to this. So we'll add a series which has signal plus noise, x value is this guy, and y value is, oops, this guy here. So there we go. Okay. And okay. So there we go. And I'm actually going to merge these cells here. And then this guy here, I'm going to merge, wrap, and center this guy. And this is because FFT returns a string. Oops, a string, not a strong. Okay. Put a box around you. Now we're going to add a button for that IFFT. And we're going to go to Developer, Insert a button here. That's going to be the IFFT, okay? Edit that guy to be run IFFT. Okay. All right. So we are totally cooking with gas now. We're going to add now. So we have the two plots here, right? So I would simply like to make that guy a different color. So I am going to actually select not that guy, but the first series. Let's make that guy black. So we can format that selection. Go here, line, solid line, and make it black. Okay. All right. So there we go. There's end of part 2 of this instruction.